We are going to talk today about the nomenclature of aromatic compounds. So we're going to be using a few rules. Some of them we know already. In general, let's say that we always need to identify what we call the parent chain. And we're going to say, what is that parent chain in the case of this aromatic compounds? Then after we do that, we need to identify substituents and of course, give it a name. We need to also number the chain so that we give the substituents in the main functional group. The main functional group has priority, and then the substituents, the lowest number possible, the locant. Then we're going to be listing alphabetically. And in some cases, we need to specify stereochemistry. So we're going to add that, stereo. So what are those main, the parent chain in those aromatic compounds? So there will be a few that we need to learn. Of course, we have benzene. And here is your C6H6. It's benzene, right? But there will be a few more that already have one substituent that have names that we need to be using. For example, methylbenzene is called toluene. If we have this right here, benzene, if we have an OH, this hydroxybenzene, but we have a name for that, and that's phenol. If we have an amino group, we're going to call that aniline. We have still a few. Let me add something here. Taking advantage of that ring already. And if I add a methoxy group here, this is anisole. And there are a few more. Now I'm going to abbreviate. This is a phenyl ring. And if I had this, which is an aldehyde group, it's benzaldehyde. And if I have the phenyl group ring, and I have this, a carboxylic acid, this is benzoic acid. So these names we actually need to learn. We name after many compounds using those as parent chains, not only benzene. And again, we can say methoxybenzene, but more commonly we'll be saying anisole, or here methylbenzene is toluene, and so forth. So now that's a strategy that we're going to be using. The other thing that we want to mention is that when we have two substituents, we also have a specific notation for that. So I'm going to now remove this and give you examples. And I'm going to be using isomers of methylbenzene, which is the common name for that, that's toluene. But if I add another methyl group, we want to know, specify what is the relationship in that substitution. Say that I have I grab toluene, but now I add another methyl group. When I have to, that will be dimethyl benzene, 1,2-dimethylbenzene, but this we're going to call 1,2, and this is xylene, but more commonly we say ortho xylene or O-xylene. Now, when the relationship, when there is, you have disubstituted, say benzene, that relationship, 1, 2, we say they're ortho, one close to the other. So, but they can also be another way. So let's see. Another isomer. We will have now, this is, I'm going to rewrite out 1, 3, let's say here, instead of 1, 2, xylene, let's write the, as from benzene, 1, 2, dimethyl benzene, and this will be 1, 2, 3. Notice that we need to give this to the smallest number possible. I don't do 1, 2, 3, 4, and 5. Instead, I do 1, 3 to give these two substituent at the benzene ring the smallest number possible. Now, this is the 1, 3 dimethyl benzene, or we can also call it meta, and that's a common name, xylene, or M xylene. And if we have these substituents in a different relationship, let's say that now they are 1, 4 in, 1, 4 is 1, 4 dimethyl benzene, 1, 2, 3, and 4. Now this 1, 4 relationship, we're gonna say this is para or P and xylene. So xylene is a name that we give all of these dimethyl benzenes. And then we have the ortho, meta, and para-xylene. And so xylene is a common name, but we know these are 1, 2 dimethyl benzene. We're going to keep doing more nomenclature exercises applying this rule. So we have some parent chain that we need to remember, not only benzene, but know what is phenol, what is aniline, anisole, styrene, and benzoic acid, benzaldehyde. All of those we need to learn. And from that, we're going to be naming aromatic compounds that will have more substituents.